Hi, this is Hilal. In this video on Mathematical Economics series, we will solve a numerical on the income determination model. The question is, consider a simple income model that is y is equal to c plus I plus g, where y is the total income, c is the consumption function, I is the investment, and g is the government expenditure. Where the consumption function is given as a plus by, where a is the autonomous consumption, b is the marginal propensity to consume. Here the I is equal to I naught, which is here the investment is given as the autonomous investment, that very investment which doesn't depend upon the level of income or interest rate. Also the G is equal to G naught, which is the autonomous government spending, irrespective of the interest rate or other stuff. These are the independent variables here, or we can say these are the exogenous variables. Find the dy by db. We have to find the effect of change in marginal propensity to consume uh, to the total output. We will see this question. Okay, first of all, we will write this equation. Y is equal to c. Our c is given as a plus by plus I is the I naught plus this is G naught. Solving for y, that is y minus by uh, is equal to a plus I naught plus G naught, or y 1 minus b is equal to a plus I naught plus G naught, or y is equal to a plus I naught plus G naught divided by 1 minus b. Okay, so this is our y. Now we have to see the effect of change in the b on the total production. That is, we have to see the change in the total production with respect to change in the marginal propensity to consume, and these are hold constant. These are the exogenous variables here. These are rather the fixed values. Okay, then this means we have to differentiate this very question, this very relationship. So we will use the quotient rule of differentiation. So that says dy by db, which is equal to, what we do in the quotient rule, first we write the denominator, that is 1 minus b, then take derivative of this dy by db, a plus I naught plus G naught, minus take this a plus I naught plus G naught, and differentiate this b by db of this 1 minus b. Actually, in economics, we don't use the quotient rule frequently. So I will show you how we do this. That is 1 minus b to the whole square. Okay. First, I will show you what is the quotient rule. Quotient rule says, if we are given the function like f, if we are given f of x and g of x, and we have to differentiate this very function. So what we do, we write first g of x and differentiate this f dash x, minus we take this fx and differentiate this g dash x, and square the denominator g x square. I guess it is like this. We use the quotient rule. Okay, what we did here, first we wrote the denominator and differentiate this very term with respect to b. Then we write minus and write this very term again, and then we differentiate this 1 minus b on this side, divided by 1 minus b whole square. Actually, it is a quotient rule formula. You can see in the differentiation chapters. Okay, now solving this, here it is 1 minus b. Now the derivative of constant is 0, so this whole will become 0, minus here we have a plus I0 plus G0. Now the derivative of b is 1, so it is here minus 1. Okay, what we get here? We get here minus, minus into minus is plus, so we get a plus I0 plus G0 divided by 1 minus b whole square. Okay, or we can write it as, we can also write it as like a plus I naught plus G naught divided by 1 minus b times 1 divided by 1 minus b. Okay, we know this a plus I naught plus G naught divided by 1 minus b is equal to y. So in place of this we will write y. So I will take the star here to differentiate it. So this is y. So our dy divided by db is equal to y divided by 1 minus b. Okay, this very relation tells us that this very relation tells us how the income will change if there is incremental change in the marginal propensity to consume, if there is small change in the marginal propensity to consume. Okay, I hope I make myself clear. Thank you.